let me pick. So you are the one you do the, I will just be picking. So not because there are so many questions that will not waste, but at least we'll start. So those are the things you'll be practicing yourself. If you have any problem next time, you let me know. So I've done all these questions. So as we are doing topic by topic, I'll be getting and forwarding it to you. Now, two positives, I think opposite the how to calculate result and opposite. Opposite we subtract. So
Subtract.
when an opposite here, you subtract. So the answer of this is going to give like 7, Abby. That's to give you
Yes.
7. 12 minus 5. Okay. At right angles, I think you can also to do. We're going to use Pythagoras theorem.
Pythagoras theorem.
Yeah, so you don't need to waste time on that one. So that should give me
But I have
13.
a question.
This should be 13,
Okay,
12,
that
5.
bracket would be okay. So it's 12 squared
It will
plus
give you,
5 squared,
yes, it will give you
13.
13.
18. Okay.
Now,
Yes. Next question.
yeah. Question B now. An object of rest on the smooth, you have this. Now, you to calculate what the resultant force. So you have to resultant force must be a one that will oppose
So
any other
it's
two.
result.
So number one, who is talking? So to draw this, it must be the line that will oppose the other two. Look at the movement, look at the arrow. I see they start like this, they're moving like this. So the resultant force must oppose other two. So the arrow of resultant force has to be like this. Yeah. So if you have to draw the arrow down, that will be like this. Because the arrow must, you can see now. So when you start the journey moving like this, move like this. So when you come and come, you are being opposed by this. So this will be resultant force. So resultant force
Then we
should be
use
the one that
cosine.
you said?
Then we use cosine to find that side. Cosine rule.
Yeah. So you are going to, in this case now, you are using the one that faces resultant force. When you are using the angle that faces resultant force, you are going to have plus in the formula. If you go and check the note, you still have plus. Now, normally when you have coming, so you are going to have okay minus in the formula. So you are going to have minus in the formula. There are two formula I give inside that note. When you are using the one that is facing the resultant force, it's going to be minus. When I'm using the one coming from, for this one now, look at the angle, look at the result, they are facing each other. So we are going to use something like the resultant force will give you square root of, that will give you 8 square plus 55 square
18.
minus, okay, 18, sorry, minus 2 times 18 times 55 cos
1, 5.
115. Yeah, so that's it.
Okay, I have a question. Like I always get confused when it comes to the direction of the resultant vector, like where it points.
It depends what they're asking now. What are, this now, did they ask us to calculate the lesson here? The lesson with what? To what? To 55. The lesson with 55 degrees to 55 force. So which is going to be now?
Oh,
This is 55. So what are they asking for? They're asking for here. This is the resultant force. This is resultant force with 55. That would be this place with 55. Let's say it's with 18. It should have been what? Yeah, it should be here. This is with 18. Because this you can see now 18. This is 9 for 18. So resultant force, and the question say with 55. It depends what they're asking you. So this one is saying with 55. This is resultant force with 55. We are looking for this way with 55.
okay.
Is it understood?
Yes.
Okay. So using this one now, you can go and use sine rule now. You can use sine, not called sine rule, this over sine this. You can use that of 18 over sine theta is equal to this over sine this. So calculate this. What do you press calculator for this? So whatever you get over sine 115. So can you calculate that?
Okay. The answer is 64.697.
Okay.
64.
65.
Yes, 64.697. So it's just 65, I think.
0.69 abi. So let me say 50. 695. So look for this. If you are looking for this, that will give you, this will not give you theta is equal to, or if I first of all do this, so you can press everything together. So that everything will give you arc sine, you know. So that will be this 80 sine 115 over 64.50.
Okay. 18 sine 115 divided by 60.
You know how to apply this, you have to use shift here, how to apply arc sine, sine inverse, sine inverse.
Yes, 14.6.
Okay. So whatever you get, that will be the answer
Wait,
to that.
sis, I have a question, sir. I forgot how to use sine rule.
First
So
of all, press sine rule.
yes, sir. So when
This
you're
is
using sine rule,
this
the
is
angle
sine.
is always in the denominator.
No. Just have this one. Let's say you have theta one, and you have
Okay.
f1. You have theta two. You have f2. So you have theta three. You have f3. Sine rule means this over sine d, the opposite. Just we are going to have f1 sine theta 1 is equal to, it can be f2 or opposite of it, f2 sine theta 2, f3 sine theta 3. Just this over opposite, this over sine opposite. That's called sine rule. You can quickly put it down.
Okay. Yes, sir. We can move on.
Okay. So using the words, okay, this is even the way the question. I've done this one now. Determine the angle between resultant 4 and 55. We've done now. So question C now. Question C is that a third force is now applied to X in the opposite direction to the resultant force. Opposite direction to the resultant force. Okay. So this is what going to happen. Let's say this is resultant force. We got 64.5 something, maybe 50. This one is, it says opposite to, in opposite. That means going to be like this. Opposite, this is 80. 18 empty. Calculate the magnitude of acceleration. So how are they now? They're in opposite as well. You are going to find another resultant for because they're in opposite. Are we together? Can you hear
Come
me?
again. Come again.
Can you hear me?
I didn't
This,
catch
let's say
what
this
you
resultant
said.
force.
Yes.
This is resultant force before. And the question is say it's opposite to. This one is opposite. So it has to be like this, opposite. So how do you now calculate another
Yes.
resultant for these two? So what's the resultant for these two? You
You subtract.
subtract to MA.
Yes.
So how do you calculate
14.5.
for? You subtract. So that will give you 80 minus 64.5 is equal to MA. So you can calculate A now. So A will give you 80 minus 64.5 over M, which is 2.7. That'll give it.
And
So that will give you the answer.
it's 5.74.
Okay. So you take notes at your hand, 5.74. So that is
Oh,
that.
may you please send me that document
I'll send
after?
it to the group. No,
No,
I'll
I'm saying
send it to
one
you.
with the
No, I can't write. So I can't write. I can't write everything word for word. So there's something I will just be telling you what to do. I know what you are trying to say. I can't write everything word for word. So
yes.
so you don't need to be writing at your place. You need to be writing down. So just what I'm going
Okay.
to write now, you write the year. This is the year and the question. Write the year,
Okay.
the question number. You need to take up number what now? So this number one. That's what I'm going to do. So you're going to write the year and the number because I can't write word for word here. Because it's not going
Okay.
to even need. You see
Yes.
now,
Yes.
because there's so many things I will put in at the, I'll just be writing, might not be so it will not be neat like that. You just need to write the main points. So where's the next one now? So I want to do all this first of all. So there's the next one. Copy this. This is the year. This is the code. Now that's what you need to take notes. Or if even convenient for you at your hand, I am my student, they used to print all these things. Yeah, they used to print and write inside. If it's convenient for you. So this is the code. This is number one. Take note of that. So we want to work on this. At least, okay. Number one, you can define what is scalar, what's a vector. I think you can be able to do that.
Yes.
Okay. So what's a scalar?
It's a quantity that has magnitude,
Quantity with only magnitude. Okay. Fine. Now,
and then
yeah, do this B. Just tell me. I will tick.
power. Okay.
This
Power
is
is
what?
a scale. Power is a scale.
A scalar. Okay.
Temperature
Mm-hmm.
scalar. Momentum vector.
Okay, fine. So that's good. Now we now have this now. You need to understand this kind of question, this concept, this kind of concept. An aircraft traveling in wind. This shows the velocity of the aircraft and the air and the wind. We have look at this. You also look at it now. This is the aircraft moving, and you have someone put the air is pushing this. For instance, let's say this wind to push the aircraft. How is it going to push the aircraft? This aircraft is going to bend like this. Yes, now look at the wind now. Look at someone coming. Let's say the aircraft coming and the wind is blowing like this. So definitely the wind will affect the rest of the aircraft. The aircraft. So the wind
Yes.
would affect the rest of the aircraft. Do you agree with that?
Yes, sir.
Okay. So how is it going to affect it? Then I'll see that's going to affect it. It's going to pull it up. At least it's supposed to pull it up. It's not going to be vertical. So to pull it off might be something bent because look at you now. This thing, look at this thing. It will push this thing now. Yeah, it will push this thing up. So how are we going to draw it? So that's what we need to do. So if I to do that's going to push it now, it will push it up and it's going to be maybe things like this. The rest will change. Maybe like this might not be straight, might not be vertically straight, and at the same time, it cannot be the same direction like this. So it has to bend to maybe this one is okay. Because that's what they're asking you to do now. Look at it. The question says draw an arrow to represent the rest of the ground force, velocity. If the wind is blowing like this is coming. The wind will push it up. So it's going to be like this is the rest of the ground force. It's going to be up. It's going to push it up. So before I move on, look at what I've done and think about it very well. It's going to because you are coming, someone is coming like this now, and the wind is blowing like this towards this. What will happen? Do you think it's going to push this thing up? Do you agree with that?
Yes.
Okay, fine. So that's what it's going to be. So that will be the rest of the resultant force. So and whatever question they ask you to do, you must do it on that figure because look at it. The question say on figure. Just go and if you copy, go and do it somewhere. Nobody will mark it. It has to be on the figure. So it has to be on that particular figure. So it will be in that form. We've answered that. So the next question now, determine the magnitude of the resultant velocity. You must be able to use this one to form triangle. So you can look at the velocity. Look at this. How am I going to form triangle with this? How am I going to form triangle? Let's see. We have this. We have the okay, fine. I think it's okay. I've gotten the look at this now. This is the one coming. This is 195. You can see this one. You must be able to draw this. For you to you can see this one. So let me stop here. You can see the arrow for this one. You don't change anything. This is what? This is 28. So you see the third one resultant force. You see the way it bends? It's also be like this. You can see now. That will give you R. You see now everything corresponds. Look at it too. Everything must look at this. Look at this one. Corresponding to this. Look at it in the straight line. Look at this one. Corresponding to this. Then look at this one. Corresponding to this. You can see now. So without you changing anything, it will form. It will form on its own. So you can see now. So that's all. So we'll form a triangle now. So in that case,
So
forming a
that
triangle means
95 and 28 will be 65.
and we have to put 65, we have to put it here. Let's see. See, this one 95 is making angle between them, and this one is 65. So where will 65 be?
Yes.
20. This knock, this okay, fine, 65. That will be 65. Angle between them, 65. That's correct. So that's all. Because you can see the angle between this and this 65, this and this 65. So that's perfect. So you are using the one that faces resultant force. So how do you calculate it? So that will give me R is equal to, so 95 plus 28 minus 2, 95, 28, then cos 65. So that's all.
Yes.
So we are ready. Let me know.
Yes. So you can move on.
Okay. So we determine that. Okay, that's it. A factor. Let me see. Do I have a factor here too? Okay. Okay, let's just begin general now. If let's begin general now, certain thing and that thing. But okay, fine. So let's begin general. What is systematic random error? Describe one example for the okay, look at this now. The analog is what is used to measure is analog system. That means zero error. Does not start from zero. So what's the random error? Scattered. The readings are scattered. So that's all these are directly from the notes. Go and read them up. Scattered the readings. This one does not start from zero already. So that's what because analog is not analog now. So that's how it's going to be. Now,
Wait,
okay.
wait, say, may you please go back to that question? May you please go back to that question? There's something that I
Which
noticed
way?
I didn't.
So this is just, which this
The
one?
one that you were
Which
doing.
one?
The one for the aircraft.
So which one?
Yes, that one. Say, when they said isn't the
Wait,
part two of the question says
wait, sir. There's something. I
that
didn't even draw this. Wait. Arrow of this
that
one
one.
does not justify. It's opposite. No, I, I didn't even see. I didn't even draw this arrow very well. So I have to follow another direction. Okay. No, it's good. The formula is okay. It's going to be the formula. It's already. It's going to be the answer, but it's already the arrow. I don't. I think that diagram. I'm not happy with that. So I have to do it another way. So maybe this one has to bend like this a bit. I may choose. I think this is what is going to happen. Yeah, I may make use of this one. I bend a bit because this. The resultant force has to oppose, but the calculator is correct. It has to oppose other two. So if that be the case, I have to do this. I'm
So
coming. Do this. Okay, fine. I will follow like this. I will do in this way. The correct, although nobody they didn't ask me to draw it, but if I want to draw it, that's going to be, it will be like this. This. Let me change different. So the one, this is 90, whatever, 95. This one will be like this. This will be like this. This will be my 28. This is 95. So this will now be like this and start to oppose. Fine.
yes, yes,
This will be like this. Start to oppose other two. So let me now say angle between, let me even see whether calculation is going to be the same thing. Angle between 8, this and
so
this
so
and this
that's
is,
the answer.
so it's, oh,
Yeah.
it's even wrong. It's going to be, this is going to be 55, 65. I don't even see. They will be here now. This is 65. So they will be, so apply it from 180. That's one what? 115, I mean.
One
So apply it from 180, 115.
it's 115, 115.
115, no, 125, 125, Abby.
115. 180
Okay,
minus 65, 115.
15, 15.
Mm-hmm.
115 is 115.
Yes.
115, yeah. So that's 115. This will now be 115 here. Uh-huh.
Mm. Focus that.
Be different.
Yeah.
Thank you. I didn't even
Yes.
see. So this because 5. So this, yeah. So it's 115 that will be here. Yeah. Mm. Fine.
Okay, we can move on now.
So units, okay. Okay. Let's just add everything. Let's pick this one. Picking this one, you have, hold on, give me like, let me plug my phone. Okay. This particular one, you can see now, define force. Don't worry. We'll do that
First,
later.
me
What is what? Force is what?
is equals to me.
No. Can you say that's not how to define it? No. But we'll do it when we get to that topic, we'll do it.
Last time,
So it's not,
acceleration.
it's defined as the rate of momentum.
So why can't I say mass times acceleration?
It's not correct, it's not accepted. Take note of
Oh,
that. It's not accepted.
oh, okay.
Because there's some, you see some paper one that both of them, this is an option. Maybe option A, option B, mass times acceleration. Two of them are together in the option. So you should know it's not correct. So this is the correct, according to this is the correct one.
The rate of change of momentum. Okay.
Yeah, it's a momentum. Unit of force, SI unitary, state the units. So that will give you a kilogram, meter,
It's gram
per second square,
meter
per second square.
second.
So use
Yes.
the definition. Use the approved experiment to determine the unit of E. So we can see now, this is,
Unit of
uh, you want to
wait.
determine for, so we
Okay.
want to determine the unit of this one. So from here, you can see charge. So it has to be SI unit. So charge, what is charge? Charge is what? IT, the formula for charge. Q is given
Yes.
as IT. So this is ampere, this is seconds. So that's the unit of charge, ampere seconds. So you are looking for units. Yeah, you don't need this one. It's a constant, it does not have units. So forget about it. So you have F is equal to what? QQ. Forget about Q1 and 2. They are the same thing. QQ over, you have a radius cell over R square E epsilon. So this is distance. So first of all, make this is solve your formula. That will give you what? F over Q or Q square. That's all. Yeah, put the unit of each of them there. Unit of this one is kilogram meter per second square dot unit of this one distance. What is of distance? Meter. That will be meter square over what unit of Q AX. What's another Q? Your AS. I do the mathematics now. So if you do that, so that will give you meter, that will give you kilogram meter cube x t. So that will give you a square s square. So if you do that, so what happens if you do that mathematics now? That will be kilogram, yeah, meter cube x minus 4 a minus 2. Yeah, mathematics. Hope I'm right with that mathematics.
So charge. Okay. Yes, sir, you can continue. You can move on.
Okay.
Just took a screenshot.
So that one is down. So random error. So this one mean how do you check on an instrument? So not starting from zero. Reading not starting from zero. So that will
Yes.
be the this. Okay, this one mean random error mean not close, far apart. So not close, not closer to each other. Now moving on to this type now. So you have V and you have a resistance label. You have the what? This is the V. This one is the resistance R. Calculate power. So under electricity, all these there are formula we're going to use for this. There are three formula for this here. You have power is what?
I
IV
squared R.
I square R. So power is also for V square over R. So then we are making use of this one because we have R on this. So calculate
Yes.
power. So give you V square over R. So V
Yes.
here is 5. R here is 125. Give me the answer.
1/5. One.
Give me the decimal. And then
Okay.
give me the decimal. Just give me the actual value.
0.2. 0.2.
0 point what?
0.2.
Okay, 0.2. 0.2. Fine. If it's 0.2, fine. Now calculate the percentage of certain thing in power. And now we are moving to
Okay.
join now.
It's
So hope you are
zero
noticing this.
point
You just
one.
coming on that.
0.1
Just
and 2.
no, I'm coming. Just hold on. You can be
Okay.
noting this because it's the same person. You want to work on this question. You can be taking note of the page. Maybe the where the question start. This one now starting from page 18. You can take note of the page. Maybe question page 18. So this is solution to that. Or you can write down the question.
I've been
Then you
taking.
now write the number. Okay, you have been taking note. Okay, fine.
Yes.
Now calculate percent of certainty. What it
0.1
is going to
from
uh, let me let me confirm that whether you know whether you got it right before I can say I'll be satisfied with your answer. V square over what? So how do I write the formula? Uncertainty is P over P times percentage, 100%. That's how to write the formula. Is equal to this is having power. You put it behind. Uncertainty is V over V times
yes
100 plus
R.
is plus, so you don't use over. I have
Yes.
R over R.
R.
I want to test over R. So maybe you
Yes.
understand this concept. Okay, fine. So this is you are looking for the this is I'm coming. The old this V is not even given. So 2 oscillating in V is 0.1 over 5. That is
Yes.
0.1 over 5,
5
100
times
plus this one is given. The OD is given. It's given already. The OD is given. It's not times, it's plus. So this is given
no,
as 3.
I said times 2 from the
Okay,
power.
and this
The
okay, this
power.
one is 3. I know this one is
Yes.
3. So plus 3.
Plus
You are wrong. I don't think so. Yeah, what's it going to give you? You have to do this one.
times 100 plus 3, 7.
And
7%.
you see now. And you are saying 0.1. See? So I wanted to find out whether you get the concept. Okay, fine.
Oh,
So
I was going to say 0.1 over 5 and express it as a percentage uncertainty. Then I multiply by 2 and add
so
the 3.
determine the value of power now with absolute certainty. Proportional number of scenarios.
No,
Absolute certainty in power. That's what you are looking for. But remember, you have oscillating in power over power times 100.
v
It gave
squared
us
over r.
7%.
Yeah,
No, you don't need it again. Just
plus
continue. This one gave 7%. I mean,
0.2. Plus
so this
0.2.
is I'm
The
coming. This one, which one
oh,
is
absolute.
0.2? You are
Yes.
looking for absolute certainty in this. So this cancel
Yes.
this. You
10%
are going
time.
to have certainty in this over P is equal to 0.07 divided by 100. Are we together?
Yes.
Okay. So you are now looking for absolute certainty in P, which is absolute certainty in P is equal to 0.07 times P. What do you get as
Times
power in the
2
first place? 0.07. What's the power?
plus 0.2.
0.2. Okay, 0.2. So what does it give?
0.014.
0.014. And it must be taken to one Tegrevan figure. So it has to be 0.01. Is that okay? Must be taken
Yes.
to one Tegrevan. So you are not going to use the answer. Yeah, if you write the answer now, the answer will be like this. So this is 0.01. How many decimal places?
It's supposed to be to 2 decimal places.
There's no particular range. The question will follow the way it is. No particular method. This one is how many ceramic? It's 0.01. How many ceramic?
Said 2.
How many decimal? How many decimal? How many decimal places?
2.
2. That means the value of power and also should be taken to 2 decimal places.
0.2.
What value of power is
Yes.
0.2? So that
0.2.
should be 0.20. So that's correct. You can see now. So they must have the same number of decimal places. This is 2. This is also 2. We are going to do more of this. Do you get the concept now?
Yes.
Okay. So that's that. So we are done with that. We are going to
Say,
do
do you have
yeah.
a question on calibration curves?
On what?
Calibration curves.
Calibration what? Caps. I don't understand.
Curves. Yes. Calibration curves. It's under um
I don't,
this chart. Hello.
I don't understand the concept.
Say
Calibration.
calibration curves.
Okay. There's nothing like calibration. There's nothing like calibration under this topic. I what I say.
Yes, there is like in paper one. Okay. No, it's fine. I'll send it to the group and show you what I'm talking about. Let's
Are you saying
continue.
it's under this topic?
Yes, sir.
Doesn't like
But it's
calibration.
usually So they usually examine it in like paper one. Let's continue. It's fine.
Maybe
I'll send it to you.
it should be past one. There's nothing like calibration curve in the current syllabus. Yeah. So maybe maybe in the past one, in the syllabus you are using now. So there's nothing like that. There's nothing like that topic, calibrate something, 2020 something. Just hold on. So I don't think. Let me see. Come. It has to be 2020. So wait, so you are still using 2024 because you are writing November, abi? It's still going to be 2024, 2022 to 2024. So that's what you are still going to use. And the beginning of the just okay.
Like,
You still go with
look,
2020. No, I'm coming. You might say in the past one, but not the one you are going to write. Not I want to say. I'm coming. Let me see. Okay, I'm coming. So don't be disturbing yourself. This is your syllabus you are writing for this page June. This is the form. So you can this is the beginning. Now nothing like calibrating something here. So you can see go and check my everything, estimate uncertainty, listening. These are the things you need to do under this topic. You can see the error uncertainty, scalar and vector, and that's all on that question one. So that's all on topic one. So nothing like calibration. Say you will see in the past one, that will be the past one,
say,
not 2020.
like, okay, those
Not
is a
not
question.
20,
Like, okay, let's
wait,
say,
not not 20, not from 2022 to date. It's no longer in syllabus. That's what I'm telling you. Is that okay?
yes, say,
If you go and see, because you like to go and deal with 2027 or 29, no, 2006, 2004, 1, you might see those ones there. But this current one, don't be bothering. Just stick to yourself. Do have a copy of syllabus. So these are the things you need to do. These are
yes,
things they
sir.
are testing you. Don't be wasting your time on unnecessary on. You have them in the past, fine. I used to tell my students, if you come across, you might not do it because I'm not going to teach you because I'm not going to syllabus. So let me focus on syllabus. But you see the past question because it was there before. There are so many topics that were there, but they're no longer available. There are also new topics you will see that are no longer in the syllabus that was not in the old one. So okay, picking up from here, divine velocity. What is velocity? Divine velocity. You can just say
Velocity,
displacement over time
rate of change.
of displacement, or you can just write it, or you write it like this. It's accepted. So here now, I want to test you here. So use this data to calculate the value of K. Yeah, from here. Calculate the value of K for me. Use this data from here. So
Okay,
I'll be waiting.
okay. 8.3 times 10 to the, okay, 8.4. Let me just round up. 8.4,
Hey, point what?
8.4 times 10 to the power 1, 2, 3, times
8.4.
to the power 8
8.4. Power what?
times 10 to the power 9.
9, like this.
Yes.
Okay. Did they ask you to give the unit? They didn't put the unit? Okay, fine. I don't want to put it again. I don't want to continue.
2, 3, 4, 5, 6, 7,
I
8.
don't, are you sure it's correct? I don't want to, I don't want to confirm it. So let me believe that you said it's correct. Is it okay?
I
What do you
confirm.
want to say?
Confirm.
Is that
Confirm.
what
I'm not confirm. I'm not
has to
sure.
confirm?
Yes.
Ah, it's supposed to be split this one. So square both sides. That's to give you V square. That will give you KP over rho. So we are looking for K. V square
Yes.
rho over P. Is that not what you
Yes.
did?
Yes. That's what
And,
I did.
and you, so you are putting this one, you square this one. Yes or no?
Yes. Yes.
Okay. Times power. Okay. And let's see. That's
9.9.
supposed to be there. Okay.
Oh, if that's what I was supposed to do, then it's fine. Sure. No.
Yes. Now. So this is this. Be another thing. This is supposed to be 9.9 power 4, are we?
Yes, sir.
If it's squared. Okay. Now you this answer in bits and data from determine the value of k with absolute certainty in k. That's what you're looking for. So k is let me first of all
Okay,
give you
let me
this.
do it. Let me do it first. Okay, let me do it
And you
first.
are going you will do it, calculate certainty in k. Do it before I have to check it, but don't do it for let me see.
Percentage uncertainty in K. So I said 12.
Okay, it's
Hello.
12, Harry.
Yes.
Are you sure it's correct? So that I'll not should I look into it and see?
Yes, sir.
Okay. What? Uncertainty, just 12, Harry.
Yes. As I said,
I don't think so.
percent
If
times
it's 12,
2% plus
if
6.
it's 12, I might not believe it because it's supposed to be once we have to go. But let me quickly look at it. You can see now
Supposed to be what?
they are in percent
Oh, I can see.
they are in percentage. You can see now. So you have to express this in percentage of certainty. So you have to be this in K over K. It has to be in percentage because those things are in percentage. Percent is equal to 2 quantity in V over V. You must be able to get all these things. So certainty in density over density times
I
one
can't see.
hundred percent.
Oh,
Ah, I don't know what's happening. I'm sharing now.
okay. Yes,
So
yes, 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 yes,
is your
yes.
network of your is the network at
I
your
can
end there?
I can see the screen now. I can see the screen now.
Okay. Certainty in K over K. You have to explain the percentage
Oh, it said absolute.
is
I
equal
thought
to
it said percentage. Oh, I didn't do that.
it is absolute, but look at what we
Oh, so I thought they
are
said
giving.
percentage.
You are giving in terms of percentage. So
Oh, yes.
no, they are in this
Oh,
all this
but
value you are giving
after
percentage.
finding,
So
wait, after finding the percentage uncertainty, say, can't I just say
okay, just
that
hold on. With
times
this.
times times the value to get the absolute? Like instead of doing all that,
No. Don't listen. No. Just listen to the method now. So
I
let
can't
me
do
do
that.
it properly.
Okay, let's see if we get the same answer then.
Uh, the answer that you got, I'm not really sure. Plus writing a P over P times 100. Uh-huh. You have been given in percentage. So you have given the whole of this without two. You have been given
Yes,
to be
yes.
you have been given to V to be 3. So that's 3. So this one give you 2 multiplied by 3% plus the whole of this you have been given in density 4. The other one 2. This is 4% plus the other one 2%. So everything is 6, then that will be 12%. This is not what they asked you to calculate. It's uncertainty now. So you got 12 here. So you are not going
Say,
are you with me?
oh, yes. I couldn't see anything before, but now I can see the screen, and I couldn't hear what you were saying.
Just multiply
So what were
this
you
thing
saying?
now. I
Okay,
multiply. I think the network.
okay, yes. Sir. Well, hmm, 1 times 10 to the power 9.
Okay. I'm coming.
Is it even possible to get an answer like that? Hmm. Or me?
You see what? Well, when you multiply, what do you get?
1 times 10 to the power 9.
Of 9. So, okay. So in this case now, provided if your code is correct, fine. And it has to be taken to once, okay, once we go. So, which is correct? So one is power 9. Both of them are 9, 9. Abi. So the answer is going to give you here now. This is 1. This K is 8. This whole number. K has to be whole number as well. Because it has to be the same. That will give you 8 power 9. So this is 1 power 9. So that will be the correct answer.
Okay, so the number of decimal points for the value depend on like how many decimal
This
points the 20
this
has.
one this is this one that will determine, or certainty that will determine what will be the number of this. This one is whole number, right? So that means this value of K has to be whole number. But let's assume this is 1.5 power 9. This is 2 decimal places. That means K has to be 2 decimal places as well.
Yes, sir.
Is that taken?
Yes, sir.
Are you writing the correct thing down?
Yes, I'm writing.
Okay. So should we the next one? Do this. I want you to do this one, the next one. Let me see either you have captured this thing. Do
Yes, sir.
do a uh,
Yes, sir.
when you are done with A, do BI as well before I scroll
A, I
down.
said 0.002, 2 times 10 to the power negative 3 for A.
For A, 2 power
Yes,
minus 3,
yes,
also the
sir.
certainty,
Yes.
0.003. Okay. I continue. Let me see. Continue.
Okay. May you scroll down? It says calculate pressure and what else?
Then for the calculate person. Okay. Write this thing down. This diameter. Don't write this
Yes,
thing
I
down
wrote it
for
down. I wrote it
write
down.
this down. Okay.
I wrote it down.
Take
I already wrote
the
it
rest
down. Okay.
of the answer. Yeah.
Pressure
Be able to build
is
this picture. Yeah.
um 30 for this rate to 0.38 over I diameter is 0.0125 and um, um, 3096, which is okay. 3100, two significant figures.
Take note of what you have done. I don't want to do this, but I will go and check them. I will project the masking for you. So we'll see whether it's correct or not. It's direct. Are you done with that? Let's go. I think that's all. Okay.
That's all. Oh,
Have you done?
determine the absolute
Uh,
uncertainty in the value of P. So it's going to be 0.38, I mean 2.8, right? 2.8 plus what is done for D squared? 1.6 times 2 So it's 1.6 times 2 plus 2.8, which is 6 times the value that I did not even write down. Did I? Ish. Yeah. 6 times what? 6 times uh times 6 over 100. 185.79. 185. Wait, say.
Okay,
Say if I get
that's the answer you
185,
got.
so when I write it to
One
two
point what? Eight.
significance,
1 point what? 1 point what? 1.8 what?
5. I got 185.
1.8 what? I can't hear you. I can't hear
Wait,
you.
I got 185. 5. 5.
1.8 what? 5. Is that all?
185.79.
185. Point.
0.799. 0.7911.
Okay. Now in this case now, you can't leave it like this because it has to be one significant figure. So sanity must be one significant figure. So that will give you 200. That's all. This has to be
Oh,
200.
I thought
Causality
it said
must be one
oh, I thought it
significant
was
figure.
going
So this one is
oh,
you know what?
say.
You thought of
I,
what?
so I thought it was going to be 190.
No, it's one significant figure. This is one significant figure you are going to.
Figure
So one sig
okay.
I say of
Okay.
certainty. When I read the note, I put it of certainty must always. So write it down now.
Yes, I'm writing it down.
When I read
Wait,
those notes, oh,
yes, sir.
must always,
Wait. Yes, sir.
always complete. Be taken to one. So be
Yes, sir.
so one paper two. Yeah, paper two two. So permit me, let me go and look for it. I want to see. This is number one. So this is actually allow one. So okay, what did you get in the first one? You get 2 power minus 10 minus 4, abi?
Sir?
The first one, what did you get? The first question, okay, question 1A, what did you get?
Question 1A. Which
What
question?
did
The
you get?
one.
The one you did now, 1A, what did you get for A? The first one,
Oh,
this one, what did you
the
get
one that.
here? For this one is wrong. Oh. I don't know why you make it wrong because I can see now. Look at this thing, it's wrong. I will project it for you. So
Say to
yeah,
the power negative 4. To the power negative 4.
and what you told me is minus 3. That what you say. What of this one? Is it correct?
Power negative 4.
Is this one correct? BI.
I can't see anything. I can't see your screen.
Ah. Is your network at maybe it's just
Okay, okay, now I
upload.
can see. Let me see.
It's network.
Wait.
Yeah, check.
My God, it's frozen now. I can't see.
You see this one now. They're saying you just say allow this is even the major one. So always taking into but they are taking 190 abi. So this will be 200. But you can see now allow this. Always taking to once we have got here. Don't follow right
Uh,
this. Always taking
200.
to that's correct. Okay. So let me move to you have a lot of them to do. So you have them that's your so you go through them now. So you can now highlight which one is maybe you cannot really do. Those are things we are going to do together again.
Yes,
Is
sir.
that okay?
Yes, sir.
So that we are going to do. I wanted to go forward, but now I need to attend to something because I've received messages here. There is something I need to do based on the calculation that I have to stop by 8:30. So practice them all.
So, so tomorrow it's kinematics.
I think tomorrow, Abby, the notes. You have the notes
Eh?
already. So I need to explain before we start the sample.
Eh?
You have the note. I've forwarded all those notes to you. All the notes.
Yes,
They are with you. Go and
yes.
check your mail. Uh-huh. Okay, get them ready. So the tomorrow, same time. So I believe it's going to. So we need to end it here for today. I need to be somewhere. To be something. So thanks
I'm
for today.
asking if are
See
we
you
going to
tomorrow.
do kinematics tomorrow?
And if are you okay with this one, this topic?
Or okay,
Can
I'll
you
do
do all
the
this
question.
one? Do them first. If you have any problem, let me know. If you have any problem, we'll move to the kinematics. Is that okay?
Okay.
Okay.
Yes.
All right.
Thank you.